Good morning all. Today, water animal repeller with motion sensor. This came from Lidl, Parkside brand. Right, let's get this open and take a look at what's inside. And inside we have a sort of unit with a PIR window there. On the bottom we have a sort of watery input with a mesh filter there. On the top, I guess that's the watery output. On the back there is a knob, which is probably a potentiometer, and you can adjust that from 0 right up to, well, whatever the top number is, 9. Now batteries, they must go in here. Oh, there's a sort of sealed compartment. Oh yeah, 4 AA's go in that water sealed compartment. Yeah, 2 covers over that so that the batteries don't get wet. Batteries in here. More batteries there. And this device, which I presume fits on the top, which is mechanically incredibly complex, that's going to be really interesting to have a look at, and that almost might warrant a video all of its own. Spike and main hose lock compatible water input. Ooh, the moulding's a bit suspect there, a little bit of flashing on there. Manual, and what's this stuff? A tube and an adapter, whatever they do. So it looks like it goes like this: water inlet, some sort of cap, forces water up this bit of extension pipe into the body of the unit. Now this must have some sort of 6-volt water valve triggered by the PIR. Then there's an adapter on the top here, and then there's the water spray thing. Now I think the idea of this thing, and we'll take a closer look at this, is that it rotates and then it changes direction. It's a very interesting mechanism on here, so let's have a look at that. Well, so far I've worked out that there's a mechanical bistable which works by pushing this into 2 positions. So it's stable in that position and stable in that position. So my guess is, and you can adjust these things, so let's bring these around so that the bistable has a relatively short travel. You click it one way, you click it the other way. Now I'm guessing that the idea is to redirect the water flow so that it oscillates backwards and forwards like this, but at the moment I can't quite see how this piece redirects the water flow. It looks like it runs up through here, and then there's an adjuster here. It's a very crude adjuster, but you can adjust the screw there, which slightly adjusts the position of this green thing, but I still haven't quite got my head around how this works, so I'll keep looking. Well, just for the moment I can't fathom this at all. I mean, I can see there's a bistable action which brings this lock in and out from the green piece. So when the lock's in, the green piece pulls the head round. When the lock disengages, I assume something makes it go the other way, but I can't quite see what that is, unless this relies on sort of chaotic motion, and there's a constant chaotic motion going on. But yeah, that's completely unfathomable. And the problem I've got is that I don't have an outside tap anymore, because we had a lead pipe feeding the house that leaked, and we had it replaced with a plastic pipe. And when they fitted the plastic pipe, we lost our outside tap because of some complexity with the plumbing, and we don't have an outside tap now. So I can't actually feed water through this under pressure and see what it does. I'll have to come back to this. Perhaps we'll get on with the electronics now. Right, so this thing has 6 screws holding it together. I think they're posi drive, yeah. So let's undo those 6 screws. Right, so I'm in. We've got battery compartment, lots of sealant to seal water out of the electronics. The pot is actually controlled by an extension piece there to the dial on the back, so that should be reasonably well water sealed. Now there are two wires going off to a solenoid, which you can see down there, and I thought, well, that's going to make this very awkward, but I think this just pulls out actually. It does. So now we can see how the solenoid piece works. Now I thought this was going to have a very clever motorized actuator which used very little power. It doesn't. It has a whopping great solenoid which is going to use a lot of current. But of course the thing about this is it's not on for long. It's triggered by motion, by an animal walking past it. It's only going to be on for 10, 15 seconds perhaps. So it can get away with having a solenoid controlled actuator to allow the water through, because it simply isn't going to be drawing current for very long. So yes, it is simply a big whopping great solenoid which allows water through this pipe. A board here which is completely potted. There's very little to see. It's potted up to the base of these electrolytic capacitors. There are a couple of 8-pin chips on there. I'm not even sure whether I'm going to be able to see the part numbers of those. There's this pot which has masses and masses of black gunk around it to try and keep the water out of this PCB. A couple of small electrolytics here. There's a 101 brown, black, brown. Well, at first thought I thought it was an inductor because it's got that sort of inductor shape, but actually I think it's a resistor because there's R16 next to it. So I think that's a resistor. So there's not a lot to see here. And because it's so heavily potted, it's probably, if we take this module out, which looks like it might come out, we'll see the PIR sensor on the other side. But there isn't a lot to see here. I will have a go at these screws and see if this comes out. So inside here we've got the, this is essentially a Fresnel or Fresnel lens. It's multiple lenses on there so that if you have one moving object, you get multiple images of it moving across the sensor. And then there's a PIR detector here. There's also this device here. I don't know whether that's an LED or a photodiode. I can't imagine there's any need for a photodiode because this needs to work at night as it does during the day. So I don't know whether maybe that changes the sensitivity of this if this is a photodiode. It could also be an LED. It might just light up the lens here in a, I don't know, green or red color, possibly. I don't know. Possibly if I put some batteries in this and activate it, we can see whether that thing illuminates. Now these two 8-pin ICs, this one has no markings on it, but it's clearly something to do with the PIR sensor, which I think is these 3 pins here. The little LED or possibly phototransistor is these 2 connections down here. This one you can read, it's an L9110, and that is a dual channel H-bridge motor driver chip. And I don't know whether it's dual channel in and of itself or whether, yes, I think it is dual channel. But anyway, you put in pulse width signals on the input and then you get MOSFET controls on the output. And why it needs that, does this solenoid need to be energized first in one direction and then in the other? We'll probably hear that when we put batteries in it, but that's what that is, L9110. Right, I'm going to put this back in its box because there isn't a lot to see here, and the circuit board's pretty straightforward. We can really, the next thing is whether or not we can hear anything. So let's put that back in there. I've got to get that solenoid to fit in there. The pot control knob needs to remate with the pot, which it seems to have done. Right, let's get the screws back in. Right, let's put the supplied batteries in. Ah, that's interesting. It looks to me like these are paralleled for more current, probably to drive, because you've got a pair going that way. Yes, and they're paralleled at both ends by the metalwork. So these cells are being used in parallel. So this is a 3-volt system. Does it say 3 volt? Well, it just says 4 times 1.5 volt. But it looks like the circuit runs on 3 volts. And I have seen other ones because I looked at a couple of YouTube videos of these things before I started this, and they seemed to be 3 volts. So obviously they decided that single cells didn't provide enough current. Is that the right way around? Yes, I think it is. Oh, that's an LED, because I just saw a red light come on. So now we've got to try and trigger this thing. Waiting for... I've got a feeling those PIRs take a while to balance, don't they? I can't remember. I'll wait a bit and see if it triggers. I'll leave the camera running and edit this down afterwards. Oh, there's actually a rubber bead around there. That's interesting. To keep the water out. Slide that thing on. So just waiting now until the PIR detects me or something, and we hear the solenoid go. Oh, I wonder if the sensitivity needs to be raised. Actually, I might be able to trigger it just through that. Not hearing a solenoid clunk. Oh yeah, there we go. I heard a clunk. So the red light's on, it's clicked, and it's dropped out. So it looks like the solenoid is pulled first one way and then pulled the other way. And the timing is about 5 seconds or something like that. Yes, that's interesting. So you can see the reason for the H-bridge driver. The solenoid is pulled one way and then pulled back the other way. Or is it just released? It's hard to tell. There's a very positive clunk when it's pulled in, and there's more of a sort of bounce feel to it when it drops out. So maybe it's just energized one way and de-energized the other. But yeah, a very definite solenoid clunk when this thing switches the water on. So back to this thing. It's really interesting. Water appears to just run up this tube, up this slightly angled piece here, and out of a nozzle there. Now with the green piece in its rest position, the tendency is going to be for this to rotate this way, like that. And that, when it triggers the bistable, means that the little hook there is pulling this thing round. So I can only assume that there's chaotic motion which gradually pulls this round until the bistable is tripped like that, and then this disconnects completely from the black plastic part, and then I assume that the jet deflection, because the jet runs up this green thing here, pushes this all the way back, and then you get this chaotic motion again which lashes it this way, and then it pushes it all the way back. But how fast it does it, I've looked at some videos of these things and they just seem to be all over the place. Then there's this thing which looks, it doesn't seem to be connected with the water jet in any way. It just looks like you can set, this is a cam, you can set it so that it either doesn't interfere with the jet of water coming out, or it does by simply adjusting the cam so that this pushes down a bit further and the jet of water just nudges the tip of that. But it's a very strange design. This must have been a design that's been sort of perfected over the years, and it just works, but it's a really strange thing. It's not immediately obvious how it works, other than if there's chaotic motion. So that's all I can assume there is. And I can't test this because I have no method of creating pressurized water. And we can't even fit a hose pipe to one of the taps inside the house, because all the taps in the house are of a type where you can't just fit a clamp type hose adapter on. So I've got no pressurized water, other than I recently bought what's it called, a pressure washer. I suppose I could attempt to interface the pressure washer nozzle, although it's not any kind of standard, with this and see how this works, but that would take a little while to set up. So I think for this video there's not much more I can do. I'm going to have to say cheerio.